Welcome, 7th graders, to Chapter 12, Lesson 3. Kind of going out of order today, and we're starting on page 643. I can find experimental and theoretical probabilities and use them to make predictions. There's a little bit of vocabulary in this, so keep track of that so you know what you're looking for when you hear different words. So theoretical probability is what you expect to happen. So what you think would happen. Think about when someone says, well, in theory or theoretically, they're saying, this is what should happen. This is what I expect. Okay. Whereas experimental probability is what actually happens when you conduct an experiment. So this is like you test something and those are the actual results. The experimental probability is what actually happens. So that's the difference. And we're going to look at a couple of them. So in your book, you're going to see what is the theoretical probability of rolling a double 1 using 2 number cubes. So what that means is, you know, a number cube is a dice, and you roll a dice, and dice are 6-sided. So there's 1 through 6. So if you're going to roll a 1 on one dice, that's 1 out of 6 chances. And on a separate dice, it's still 1 out of 6 chances. So what you do for theoretical probability is there's a 1 through 6 chance times a 1 through 6 chance, and that's a 1/36 of a chance. Because you remember that when you multiply fractions, you multiply straight across. So 1 times 1 is 1, 6 times 6 is 36. So there's a 1 in 36 chance of rolling double 1s. And that is up here, double 1s. So that's like snake eyes if you're a dice player. So the graph shows the results of an experiment in which 2 number cubes were rolled, so 2 die. According to the experimental probability, is the sum of 12 likely to occur? So we look over here, this is the sum of 12. So that'd be, you'd have to roll 2 6s. So we look at the reasoning and you're thinking, okay, that's not very much. That's like looks like it happened maybe one time if this is going by intervals of 2. And so only one of the 58 sums is 12. So the experimental probability, and remember it's experimental right now because this was something that was actually done in data and experiment conducted. So the experimental probability of rolling a 12 was a 1 in 58. So it is not likely, and if you are going to describe it, you do want to say likely, not likely. It is not likely for the sum of 12 will occur when rolling 2 number cubes. So referring to that same graph, we look here, according to the experimental probability, so according to the data we conducted, which sum is most likely to occur? So obviously we know 12 is not very likely. So we look, and these numbers are pretty unlikely as well. 4 is more likely. These numbers in the middle are more likely, like 6, 7, 8, 9. Since 8 has the happening of most, 13 out of the 58 times, we say that 8, because during the experiment, it came up the most times. And it looks like it came up 13 out of the 58 rules. So that is what I expect, a description, an answer and a description of what happened. So some real world examples. 300 people were surveyed as to how to keep track of time. What is the experimental probability that a person uses his or her cell phone? So we look at cell phone, okay? So we have to look at the cell phone, but we also have to look at the total number of people included. So you see is that there were 300 people surveyed, and we got that by adding up the sum here. So we added up the total, and there was 300 people surveyed, and 185 of them use their cell phone to keep track of time. So what that means is the experimental probability is 185, the number of people using their cell phones, out of the total surveyed, which is 62%. For example, you would have done that by dividing. You would have got 0.62, and then to get to a percent, you multiply by 100. So trying this one, trying on your own, pausing and coming back. What is the experimental probability that a person uses his or her watch? It's hard to read one. His or her watch to keep track of time. So we're looking at this category, and we remember that it was out of 300 total people. So we think, okay, that's going to be 57 out of 300. So it's 57 out of 300 people. So we make that into our fraction, 57 out of 300, and that should be equal to, if we simplify, 19 out of 100, which would be the same as 19%. We wanted to write that way as well. We can write 19%. So you can use past performance to predict future events. That's what probability also allows us to do. So a plant that's manufacturing light bulbs, an inspector finds that the probability that a light bulb is not defective is 8 out of 11. So 8 out of 11 light bulbs. This is the the probability experiment, mental or theoretical? So you're trying to think, um, this inspector finds that the probability of a light bulb is not defective 8 out of 11 times. We're wondering, is this experimental? So is this a result of something that was an experiment that was conducted and happened? Or is this, in theory, what we think will happen? And then you explain. So this is an experimental probability because it is based on what has already happened. The inspector did some tests. So if the company wants to have 10,000 non-defective light bulbs, how many light bulbs will they need to make? So we can do this by using a proportion. See, this chapter 4 was important. So we set up a proportion, and if we know that 8 out of 11 light bulbs are not defective, if we want 10,000 to not be defective, how many are we going to have to actually test? So we solve the proportion by setting it equal to one another. We use our cross products to solve. So remember doing 8 times x and 11 times 10,000 here. And then we multiply this side together for 110,000, divide by 8 to get x alone. And we end up with 13,750. And this is the number of light bulbs a company should make so that 10,000 of them cannot be defective. So last, check your progress here. In surveys, a recent survey, 150 people, 18 people responded that they were left-handed. If an additional 25,000 people were surveyed, how many would you expect to be left-handed? So again, we're going to use a proportion. We know that people surveyed, the total was 150. We know that out of those 150, 18 were left-handed. So we set up a proportion. 18 out of 150 is how many left-handed people out of 2,500, or 2,500. So then we're going to solve this proportion. And we do that by doing our cross products. So we multiply 18 times 2,500. And that's going to be equal, technically, to 150 times what number? So we just jumped ahead and divided for a total of 300 people. In this situation, if we surveyed 2,500 people at this rate of 18 people left-handed out of 150, 300 people should be left-handed. It isn't too bad, hopefully, and this is some real-world things, especially if you go into the world of business or testing and manufacturing. This knowing and solving proportions and doing experiments is going to be extremely helpful for you. So make sure you do what you can to understand and come to class with questions. See you then.